Okay, we get to our final example where we have a quotient or a fraction, and what can we do with it? Well, first of all, we must first see if we can simplify the numerator and the denominator. We can't do anything to the denominator, it's 3y. To the numerator, we can investigate, but we see that we don't have like terms because we have y to the power of 4 and y to the power of 3, so they have different exponents. So what do we need to do? We need to write this as two fractions. Okay, so we'll do that. We will say it's equal to 6y to the power of 4 over 3y. That's the first one. And then we use that negative sign to be in between the two fractions. So this negative sign is the same as that negative sign. And then we have the 9y to the power of 3 over 3y. Okay. Now what will we do? Now we look at each fraction individually. So we'll first look at the first one. Now the first question you're going to ask yourself is, will I be left with a fraction or not? Now let's investigate. Can 3 go into 6? Yes, there won't be a remainder. Can y to the power, or can y be divided into y to the power of 4? Yes. Okay, remember there's an exponent of 1, so we won't end up with a fraction. So 6 divided with 3 is 2. And then y to the power of 4 divided with y to the power of 1. Remember, when we divide the same base, we subtract the exponents. So it will be y to the power of 4 minus 1, which will give us 3. And then we have the negative sign. It's the same as that negative sign. Then we ask ourselves the question again. Will we be left with a fraction? No, we won't, because 3 can go into 9 without a remainder. And y to the power of 1 can also divide into y to the power of 3. Okay, so 9 divided by 3 will give us the 3, and y to the power of 3 divided with y to the power of 1 will give us y to the power of 3 minus 1, which is a square. Now we investigate this. This is our answer. Can we simplify it? Always ask yourself that question. No, we can't, because we have terms with the same base, but they have different exponents, and that makes it impossible for us to subtract them. Okay, so that's your final answer. Thanks.